Good morning, class. So we already went over the properties of logarithms, so we're going to jump right into the examples. So, example 1, we're asked to solve for x. So log base 3 of x plus 1 plus log base 3 of 4 equals log base 3 of 24. So we're going to use the properties of logarithms that we learned yesterday to solve this equation for x. Okay? So the first thing that we try to do is identify the logarithm that has the x's in it and move everything else to the other side. So I'm going to take this log base 3 of 4 and move it to that side. Subtract it on this side and on that side, log base 3 of 4. So this is log base 3 of x plus 1 equals, now don't be tempted to just subtract the 24s or do something weird on this side. We'll just write them side by side for now. Log base 3 of 24 minus log base 3 of 4. And then we notice that on this side, this is our quotient rule, that we can change this subtraction to log base 3 of this thing minus log base 3 of that thing is log base 3 of the things divided. So log base 3, just on the left-hand side, this is the same, x plus 1 equals log base 3 of 24 divided by 4. Like that. Okay? So that is our quotient rule that we applied there. Okay? Any questions so far? Alright. So, then we have log base 3 of x plus 1 equals, and 24 divided by 4 is 6. And then we see that we can use that rule that says that if we have log base 3 of one thing equal to log base 3 of another thing, then the two things on the inside are equal. So x plus 1 must equal 6. So then we subtract 1 from both sides, and we get x equals 5. Now, are we done? Nope, we actually have to check for extraneous solutions with logarithmic equations. That means we need to plug this back into our original equation and see if it works. Now, why would we need to check for extraneous solutions? And it has to do with the domain of logarithms. What is the domain of logarithmic functions? Does anybody remember? Good. It means you can't put any negatives or 0 inside of logarithms. Whatever goes on the inside must be positive. So we're going to check our answer, check. So we plug in x equals 5 back into the original equation, log base 3 of 5 plus 1 plus log base 3 of 4. Does this equal, so I'll put a little question mark above the equal sign, does this equal log base 3 of 24? And we'll get log base 3 of 6 plus log base 3 of 4. Does this equal log base 3 of 24? Now there are a few ways that we can do this, but we could use our product rule here. When we're adding here, we can multiply the insides. Remember that. So log base 3 of 6 times 4 is 24. Does this equal log base 3 of 24? Yes, it does. So x minus 5, or x equals 5 is our answer. Okay, any questions on that? All right. So, another example that we can do is like this one. Log base 2 of x plus log base 2 of x plus 2 equals log base 2 of x plus 6. Now, we see multiple x's in here, so we can just start combining the logs instead of trying to just identify the one that has x's in it and isolate it. There are multiple logs with x's in them, so let's use our product rule right away on this left-hand side. So log base 2 of x times x plus 2. Careful here to multiply that x by both the x and the 2, that's why I put an extra set of parentheses in there. Log base 2 of x plus 6. So this is, and then we can also use the rule that says log base 2 of this equals log base 2 of that, then the insides must be equal. And I'm going to distribute this while I'm at it. So x squared plus 2x equals x plus 6. And then we can solve this like a normal quadratic equation. So we move everything to one side, set it equal to 0. We get x squared plus x minus 6 equals 0. Factor into x plus 3, x minus 2 equals 0. And then we get x equals negative 3 and x equals 2. Okay? Now again we have to check for extraneous solutions. And we have to check both of these. So let's check our x equals negative 3 solution by plugging it back into the original equation. Remember, what's the domain of logarithms? What can't we have on the inside? Negatives, right? So right away we can see that plugging in log base 2 of this one into x gives us a negative 3. So there's a problem there. A red flag should go up. Problem. So x equals negative 3 is not a solution. So we discard that one. Now we check x equals 2. Log base 2 of 2 plus log base 2 of 2 plus 2. I'm just plugging that 2 in for every x I see up here in the original equation. Equals log base 2 of 2 plus 6. And then again, there are multiple ways to do this, as we've learned, but you could just do this. Log base 2 of 2 plus log base 2 of 2 plus 2 is 4. Does this equal log base 2 of 2 plus 6 is 8? Log base 2 of 2, that's one of our properties of logarithms as well, right? That's 1. Plus log base 2 of 4. You think 4 raised to what power gives me 2? It's 2. Log base 2 of 8, what 2 raised to what power gives me 8? That's 3. So 3 equals 3. So that checks out, and that is our solution. Thank you. Oh, not thank you. Now try it on your own. The examples that you have on your worksheet, which are on my class notes, so you can take a look at those, Dr. Williams. Now thank you.